Your application is down and you try to test the connection. First error is connection refused. Then another test shows connection timeout. Then the third test shows no route to host. Most engineers treat all three as network issues. That is wrong. These three errors are completely different. And if you understand the difference, you can troubleshoot production much faster. Today, I'll show you all three errors using real commands. We will break things and read the evidence. If you are new to my channel, make sure to hit that like button, subscribe, and comment networking if you are following this series. Let's start with the healthy application. Now let's try to run this healthy container. For that I am using docker run command followed by the name web application, port and the nginx. Press enter. The container got created successfully. I am going to run docker ps just to see if it is up and running. Yes, it is up and running. Now let's try to test that real quick. For that I am going to say curl http colon localhost port 8080. Press enter and I can see the output. Thank you for using the nginx. This looks perfect. Now let's try to check the listening port as well. I'm going to use tulpn command for that. Tulpn pipe. I will use grep port 8080. Here the output looks perfect. 8080 is listening correctly. Right now everything is healthy. Container is running, application is also responding, our port 8080 is also listening. This is important because before troubleshooting failure, you should know what healthy actually looks like. Now, let's try to connect to the wrong port. Now, let's try to start with our first incident. First, I am going to connect to the wrong port using nc command. Press enter. You see the error? Connection refused. This is our first incident. This does not mean that server is unreachable. The server answered immediately, but nothing is listening on port 8081. Now let's try to prove that by using ss space hyphen tulpn pipe grep 8081. Press enter. Nothing appears. Now let's try to check the port 8080. Here you can see port 8080 is listening, not 8081. So the problem is not the machine here. Also the problem is not routing or DNS. The problem is very simple. We tried to connect to a port where nothing was listening. Now let's talk about some production examples. Right now we saw wrong Docker port. Same will have Kubernetes target port where you will see application is, let's say, crashed, and also sometimes database is not running. Service might point to the wrong backend port. Always when you see connection refused, first ask, is anything actually listening on that particular port? Same like we did here. We tried to run this command and we saw if something is actually listening. And then we tried port 8080. This is how you are going to troubleshoot. Now let's jump into the second incident. Now let's try to talk about incident 2. For that, I'm going to use this command. This is completely different again. Here, Linux is not saying the port is closed. It is saying, I don't know how to reach that host. No route to host. Before the packet can reach any application, your operating system checks the routing table. For that, I'm going to run IP route followed by IP address. This is routing. Your machine is asking which interface should I use? Which gateway should I send this to? Do I even have a path to that particular network? If the answer is no, you get no route to host. Now let's talk about some production examples. Wrong subnet is, let's say, one of the major problem. Missing route table entry is another problem. Broken VPC peering. Kubernetes CNI issue. No route to host error. Don't start with application logs. Start with routing. The command which I showed, IP space route. Now let's try to talk about the incident 3. For that, I am going to do some setup. On my virtual machine, I am going to block this particular port 8080. For that, I am using this command IP tables input TCP port 8080 J drop. After dropping this, I am going to run HTTP server on port 8080. Press enter. This is running fine now. Now I'm going to jump back to the terminal and use netcat command followed by the IP address and port 8080. I am waiting only for 5 seconds here. This is connection timed out. Notice the difference. In connection refused, Linux replied immediately. In no route to host, Linux did not know how to reach the network, but here the route exists. But here the route exists, also the port exists, application is also running, but the firewall is silently dropping packets. This is why nothing comes back. Now let's try to remove this firewall rule real quick. I'm going to run sudo IP tables -d input 1. This is, let's say, row number 1. Press enter and followed by I am going to run that Python server once again. Come back to my host machine. Here I will say nc-vz IP address and the port. We can see connection succeeded now. This is exactly what happens in production with Azure network security groups, AWS security groups, network ACL, Kubernetes network policies, corporate firewalls, load balancer. The application may be completely healthy, but the packet never reaches it. When you see connection timeout, don't think something is silently dropping traffic. Now, once again, let's compare all three real quick. First, I'm going to do localhost 8081. The server replied, the port is closed. First, we are going to check -tulpn pipe grep 8081. No route to host. We are going to run IP route command and check the valid route. And finally, we are going to drop the port, run the Python server, and then we are going to check the connection. After 5 seconds, we are going to see connection timeout. Imagine this is production. Payment service connects to Redis server. One engineer sees the error and says, restart Redis. Another says, check firewall. One more engineer will say, check Kubernetes logs. But the best engineer first reads the error. If it says connection refused, they check whether Redis is listening on port 6379 using ss space hyphen tulpn command pipe grep 6379. If it says connection timeout, they will try to check firewall, security group, network policy. If it says no route to host, they check routing, VPN, subnet, and gateway. Same application, same dependency, completely different investigation. This is the difference between guessing and troubleshooting. Always remember, connection refused means you successfully reached the machine, but nothing is listening on that port. Connection timeout means packets are going out, but something is silently dropping them. No route to host means your machine does not know how to reach that destination network. Do not treat all these errors as same because they are just clues. And in production, clues will clues will save lot of time. Strong troubleshooting starts with reading the evidence. So, next time your application cannot connect to database or API, Redis, Kafka, it can be any internal service. Don't panic and also don't restart anything. Look at the exact error, check the port, read the error. This is how real production troubleshooting works. If you are enjoying this Networking for DevOps Engineer series, subscribe to the channel. In the next episode, we'll go one level deeper and understand what actually happens during the TCP three-way handshake. And comment networking if you want more hands-on production troubleshooting videos like this. Thank you for watching. I'll see you in the next video.